Hi, I'm Rob Tweed, the developer of the QEWD platform and QEWD-JSdb, and in this fifth video on QEWD-JSdb, I want to look at how you can iterate through the keys within an on-disk JSON document. I'll be using the same setup as I've used in previous videos in this series, so you should be familiar with it by now. If not, I'd recommend you watch the previous videos before watching this one. The links to the series so far are in the YouTube comments below this video. Unlike previous videos in this series, due to the nature of the demonstrations, I'm going to be using node.js script files rather than the REPL. Iterating through an object's keys is something you do very frequently in JavaScript, using for example a for-in loop, which is what this script will do. I'm creating this object, and then listing the keys within the JSDB names subset of the object. So when I run it, here's those keys as we'd expect. So can we do the equivalent with the on-disk version of this object? The answer is yes. Let's use the same object, only this time I'll save it to disk using this script. What this is going to do should be fairly familiar to you by now, but I'll quickly summarize the logic. I'm loading the JSDB shell module. That makes an in-process connection to the underlying YotaDB database, and then loads the QEWD-JSdb abstraction layer. Then I'm creating the same object as before, and then I'm saving it into an on-disk object, into a physical global named demo. This last line is something you won't have seen before. In standalone scripts like this, it's always good practice to use this close method to close the connection cleanly to the YotaDB database when you're finished. Okay, so let's run this script. And as you've seen before, the saved on-disk object is shown in the global storage view. So okay, now that we have the same object on disk, how do I do what I just did in memory, iterate through the names in this part of the on-disk object? Let's take a look. I first instantiate a document node object that represents the section of the on-disk document that we're interested in, which for this example is this. Every document node object has a method named forEachChild, which is what you can see I'll use here. As its name implies, it will iterate through all the document node object's children. The first argument of the forEachChild method is a function which is invoked at each iteration. That function's first argument provides us with the value of the last key of each child node at each iteration. So if I run it, and yes, it's listed all the names. So the forEachChild method is therefore the on-disk equivalent of the in-memory for-in loop. So that's pretty useful, but at each iteration, can I also access the corresponding child node object and do stuff with it? Again, the answer is yes. Take a look at this script. In this version, you'll see that in the function that's invoked at each iteration, I'm specifying a second argument. This argument gives me the child document node object at each iteration. And of course this means that we have access to all the child document node object's properties and methods. So in this example, you can see that at each iteration, I'm also going to fetch and display the subset of JSON under each child node. Let's see that at work. At this point, it's worth you knowing that one of the features of global storage databases, YotaDB in our case, is that they are optimized for iterating through global subscripts, which of course is what QEWD-JSdb maps JSON keys onto. This ability to iterate through on-disk keys is the basis of implementing very high-performance database searches, and it's something global storage databases truly excel at. It's this low-level global storage iterator API that the forEachChild method is using beneath the covers. Now you've probably realized that the child document node object that's returned at each iteration will also have the forEachChild method available to it. So this means we can nest forEachChild loops, which is what I'm doing in this script. For each name that's found at each iteration, I'm then finding all its child nodes and displaying their last key. Let's see this version in action. We can see from the stored data that the grandchild nodes that are retrieved within the inner forEachChild method are leaf nodes, so we should be able to also retrieve their value. Here's how I can do that. And as you probably guessed, I simply use the value property for each grandchild node. Let's see this version in action. And sure enough, you can see the values now being displayed. So this ability to nest for each child methods means that I could, if I wanted or needed to, iterate through every level of an on-disk object. For example, here my starting point is the top level document node object, and then I'm iterating through 5 nested levels of for each child methods. At each level I'm checking to see if the current child node is a leaf node by checking its hasValue property. And if it is, I'll display its keys using the child document node object's path property, along with the child's value. Notice also that I'm going to count the total number of iterations in this logic. You'll see why in a minute. Okay, so let's see this in action. And sure enough, you can see that it's correctly returned every leaf node. Now in fact, if it's every leaf node you're after, this isn't a particularly satisfactory approach. I had to know that the maximum key depth of this object was 5, and in the real world I'd probably actually not know that. It's also an inefficient way to find leaf nodes. Remember the counter that was being incremented at every iteration at every level? You can see that it took 48 iterations to retrieve the leaf nodes, and if you actually count the leaf nodes in the global storage view, you'll see that there are just 27 of them. QEWD-JSdb provides a much more efficient method for iterating through leaf nodes, and it's done using the for each leaf node method. We see it being applied in this script to the top level document node object. This time the function that's invoked at each iteration provides us with the leaf node's value as the first argument, and the leaf document node object itself as the second argument. In this script, just as in the previous example, at each iteration I'm displaying the keys for each leaf node, using the leaf document node object's path property, along with the leaf node's value. So let's see this in action. And we can see that it has indeed fetched all the leaf nodes. And you can see that this time it's just taken 27 iterations to retrieve the 27 leaf nodes. And of course the logic was clearly a lot simpler than using nested for each child methods. By the way, behind the scenes, the low-level YotaDB API that's being invoked here is also directly iterating through the leaf nodes. It's another thing global storage databases are optimized to do. Now you've probably realized that every document node object has this for each leaf node method available to it, so we aren't restricted to an exhaustive search through an entire on-disk object. We can retrieve leaf nodes just within subsets of the on-disk object, and that's what I'm going to do in this example. Here my starting point is this section of the on-disk object, and if I run it, you can see that I'm now just retrieving these leaf nodes. So that's an initial look at how you can iterate through on-disk keys. It's one of the really important and powerful features of QEWD-JSdb. In the next video, we'll look at the further control you have over for each child loops, for example limiting their range and/or their direction. We'll also look at how the keys of an on-disk object can be used as the basis of high-performance database indexing. So thanks for watching, and I'll see you in the next video.